So in this example, we're given kind of an ugly looking equation for a circle and asked to identify the center and the radius. So the goal at first here is to get this equation written in the standard form for the equation of a circle, which is x minus h squared plus y minus k squared equals r squared. And when it's written in that form, then we know that the center of the circle is located at hk and the radius is r. So we want to make this equation look like that. So the first thing we could do is group the x terms in one parentheses. So I'm going to collect the x squared plus 3x here. Group the y terms in another parenthesis. So I'll group y squared minus 7y here. And move the constant term to the other side. So I'm subtracting 9/4 from both sides. So now, like I said, just taking a step back, you can see that we're one step closer to an equation that looks like this. But the issue now is I want x minus h squared. I want to turn this expression here into x plus or minus some number squared. And then same deal for the y expression here. I want y plus or minus some number squared equals r squared. To get from here to here, we use completing the square. So we want to turn each of these into a perfect square expression. The way we figure out how much to add in completing the square is you take the coefficient of our x to the first power here, divide it by 2, and square it. So we need to add 9/4 to both sides of this equation. Here we'll have x squared plus 3x. So we've learned that the trick in this expression is to add 9/4. And I'm going to skip the y term for now. And then over here, we're going to add that same amount. So plus 9/4. Now we need to do the same thing in the y group here. So we have y squared minus 7y. The way we figure out how much to add, again, is we take this coefficient of, in this case, y to the first, so that's -7, divide it by 2, and square it. So this time we're going to add 49/4. And so I need to balance that by adding the same amount to the other side. Can't just go adding 49/4 to one side of an equation just because it makes it turn into a perfect square. We've got to balance it out. So whatever you add to one side, do the same thing to the other side. These are a little tricky to factor. I mean, so it's nice if we have nice whole numbers, but in this case we don't. If you think about factoring this, you want two numbers that multiply to give you 9/4 and add up to +3. And I don't know if this just, comes right to your, forefront of your mind right away, but 3/2 and 3/2 will serve that purpose. 3/2 and 3/2. Because notice, if we double check this by foiling, you'll have x squared plus 3/2 x plus 3/2 x. When you add those together, you'll have plus 3x. And then 3/2 times 3/2 gives us 9/4. So this factors as x plus 3/2 quantity squared. Now there is a shortcut. It's always going to happen like this when you complete the square, that it's going to factor as x and then half of this coefficient. So if I apply that same trick here, it's going to be y and then half of this coefficient. That would be, if what I'm saying to you is true, that would be -7/2. And let's see. Test that out. So y minus 7/2 times y minus 7/2. I'm going to FOIL that to double check. I get y squared minus 7/2 times y minus 7/2 times y. When you combine that, you're going to have minus 14/2, which is -7y. And then last, you'll have plus 49/4. So that's good. All right, so now just adding the values over here, well, -9/4 plus 9/4, that's kind of convenient. So that's 0. And then 49/4 here, which is 7/2 squared. So this is a circle with a center located at, so one thing to notice about the standard form for equation of a circle, you have x minus h and y minus k when the center is at positive h, positive k. So it's opposite sign. So if I see plus 3/2, I can think of that as x minus negative 3/2. So the h in this case is negative 3/2, and the k is positive 7/2. The center is at negative 3/2, and then positive 7/2, and the radius is 7/2. Radius 7/2.